Good morning. So we are with question paper problems. So May 2017 one we have already solved in last video. Now we will go with another question that was asked in 2017 is little bit different question. You can see it, a conference hall. So 8 meter by 18 meter is provided with a 120 RC slab or rolled steel beams, space 3 meters center to center. A wearing coat of 100 thickness is provided over the roof. Design the beam. So now here we have to go for design. So same question paper. So we have analysis, one question, another we have design. Now we have step one given data. Now try to understand this problem. So we have given data. Now we are already well known with purlins, and therefore you are in position to solve this problem. So now we have total this as 18 meter. This is 18 meter and this is 8 meter. Now we have 6 parts, 1, 2, 3, 4, 5, and then we have 6. So we have 3 meters. Total is given 18 meter and they have mentioned 3 meters center to center. Now given thickness of slab thickness is given 120 wearing coat is given 100 Now given unit weight of concrete, 25 kilonewton per meter cube, and therefore self weight of slab we will get equal to 25 into 0.12, and then we will get it as 25 into 1.12, 3 kilonewton per meter square, because we have live load in kilonewton per meter square, and self weight of coat, that is 20 into 0.1, it comes to, so total dead load 5 kilonewton per meter square, live load 3 kilonewton per meter square, and then we will get total load 5 plus 3, we have 8 kilonewton per meter square. Now try to understand, this is a load. If I will consider any beam, then this beam will take the responsibility of the load, which is half spacing from both sides. So we have equal spacing, so 1.5, 1.5. So this much load will be taken by this beam. And therefore we will get in UDL total load equal to 8 into 3, 24 kilonewton per meter. So this is the important part. Once we know this, then remaining things we can do it easily. So now we can have step 2, loading. So we have given 24 total load. Total load comes 24 kilonewton per meter, and self weight 0.75. And then we will get it as 24.75 kilonewton per meter. Now we will have step 3, shear force and bending moment. So now we have, if we will draw the diagram, then we have this as This is load. Now we have to make it factorial. Factorial load equal to 24.75 into 1.5, and it comes 37.13 kilonewton per meter. So this is 37.13 kilonewton per meter. This is 8 meter. And therefore we will get, that is, VU is equal to WL by 2. So 37.13 into 8 by 2. And we will get it as 148.52 kilonewton meter. Kilonewton. And MU we have WUL square by 8. So 37.13 into 8 square by 8. And this value comes 297.04 kilonewton meter. Then we have to go step 3, select section. Step 3, or I can write step 4, section modulus required. And then we will go with different step, section modulus required. Now it is laterally supported because the slab is above it. So we have ZP required equal to, now things are easy. Mu upon gamma MO upon Fy. And we have this as 297.04 10 raised to 6, 1.1 upon 250. And we will get this value equal to 1306.98 into 10 raised to 3 mm cube equal to 1306.98 centimeter cube. Then we will go step 5, selection of section. Selection of section. Now considering this, we can select, so select ISLB 450 at 640.59 Newton per meter. We have value of BF 170, TF 13.4 millimeter, TW 8.6 millimeters. Now we have step 6, shear capacity. Step 6, shear capacity. And then we have this as VD equal to Fy upon root 3 gamma MW into D into TW. 8.4 you can go. 250 upon root 3 into 1.25 into 450 into 8.6. That is 507.8 into 10 raised to 3 newtons. That is 507.8 kilonewtons. Then we have to calculate 0.6 VD, and that is 0.6 into 507.8 equal to 304.7 kilonewton, which is greater than 148.52 kilonewton, and therefore use 8.2. And then we have last, that is bending strength, step 7, bending strength. And then we have MD is equal to beta B ZP Fy upon gamma MO. But you go one step in between, so you can take it step 7, classification. I will not go for this, but you have to do it. You have 1 mark for it. that is B by TF and D by TW. And then we have this as 1 into ZP. We have ZP of this section, we have 1401.35 into 10 raised to 3 into 250 upon 1.1, and it comes 318.48 into 10 raised to 6 Newton millimeter equal to 318.48 kilonewton meter greater than 297.04 kilonewton meter. Therefore, provide ISLB. Therefore, provide ISLB 450 at 640.49 Newton per meter. So this is solution of the question. So now we will stop here only. So remaining problems we will see in the next lecture. Thank you.